Friday. Control networks. Week 5, day 9. We reviewed OSI, talked about physical layer, cables, and wireless, and radio frequencies, and a lot of things wrapped around that, and then we finished up talking about the data. So, I'll review some items here, not necessarily in the exact order that we did them. So we start off, again, talking about a browser. You got a URL. DNS finds an IP address for that. And we'll talk a little bit about then coming down through the layers. Okay. You know, we talked about maybe if it's going to get encrypted, the presentation layer, we have the link into the browser application, set up a session with the website we're going to. Then we figure out how we're going to transport the data, break it into segments, following some protocol. You know, how big are the segments? Following some protocol. And then it decides, is it TCP, UDP, in terms of how we're going to transport the data. Here's some addressing to get it through a packet switching network. So we create a packet, and we add, at this point, we add right here. We add the source destination IP. Right in here is the data that came down from up here. It could be encrypted and so forth. Okay. So then we move it down and we create a frame at the data link layer. And the same kind of thing. We get a source and destination. Now MAC address if we're using Ethernet. Talk more about that later. And now the data here is everything that was here. Okay? There are some other items in the frame. We talked a little bit about logical link control, connects us into the layers above. Media access control does what it says. It connects us into the access to the media, which now we talk about the physical layer. The ones and zeros are going to be sent through the medium using, you know, a wired solution, twisted pair, coaxial cable, shielded twisted pair, or fiber by light, or we're going to send it wireless by RF. Okay? Alright. So, some of the other things. Actually, I think we can move to the next page. Highlight some of the items on there. Bandwidth and throughput. Bandwidth, the media will give us some type of bandwidth. For example, the NIC cards in the PCs are gigabit. Right? 1 gig bits per second. That's what they can send at. Now, if you have a gigabit file and you send it in the network and you wait for it to end up on a server somewheres, it's not going to, if it's 1 gigabit big, it's not going to be here in a second. It's going to take some time to put it on the wire, get it through the devices, and store it on the other device. Okay? To get it through the network, we call that throughput, which is always less than the physical bandwidth that we're working with. Okay? We spent some time in class. We worked on a lab and we talked about the ports. They looked at ports like a serial port for a WAN on a router, Ethernet ports, and they actually looked at a number of devices and tried to determine which ports where. We talked a little bit about wireless, sending the signal through the air from our device to a access point. Alright. I also talked a little bit about the history when we used to have hubs. I'm not going to go into detail. We used to have hubs, and they would just broadcast. So this PC would communicate, and the information would go everywhere, you know, to the router, and the router stopped broadcast, but it would go everywhere. And then the PC that needed. Okay, I kind of lost my recording there for a second, so hopefully I got everything here. Let's see here. Okay, I guess I already had some of this recorded. on this page, so let me move, oh, this is the last page, okay. I'm not sure when the recording ended, but let me run through this with another color. We talked about connections, I talked about topologies, a physical topology that has all the details in it, and a logical topology is like what we draw in class. Pretty soon we'll be adding IP addresses to that, and so forth. We talked a little bit about a bus here, where you have one line. We had at Newman years ago, we had a Corvus drive running CP/M operating system, and we had some Apple IIes. Anybody remember those? Anyway, we had a whole bunch of those connected to this bus, and that communicated to the Corvus. And you could communicate between the Apple IIes also. It was pretty revolutionary at the time. Same idea works inside a PC. It has an electronic bus. Okay, talked a little bit about detail. We'll look at that more in class, where you have a rack where you have a bunch of patch panels, and you have cables connecting out to maybe something in the wall, and then connects to some PCs, and then from the rack connects to devices, and then we have vertical runs, devices connect on the vertical runs, and so forth. Yeah, we'll keep talking about that as the year goes on, but you should understand topology and the difference between physical and logical. That's it.